There is a similarity between physics and chess. It takes many years of practice to become good at playing chess. Nevertheless, the rules of chess are fairly simple, and all the rules can be explained in just a few minutes. Therefore, in reality, it only takes a few minutes to learn how to play chess. The same is true for many fields in physics, engineering, and mathematics. There are often only a few basic principles that take just a few minutes to learn, and once you know these basic principles, everything else in that subject can be derived and understood. Unfortunately, even the best colleges and universities often fail to properly explain these basic principles to the students, and this causes the students to struggle throughout their entire careers. What these colleges and universities do is the equivalent of trying to teach the strategies for playing chess, without ever explaining the rules for how the pieces move. For example, someone might tell you that you should avoid losing your queen. However, this is not actually one of the rules of chess, since sacrificing your queen is a perfectly legal move. In fact, there are some rare situations where deliberately sacrificing your queen is the most brilliant move you can make. But you would not realize this if you thought that sacrificing the queen is against the rules. When dealing with technical subjects, many people often conflate this type of advice about strategy with the actual rules of the game. This mistake goes in both directions. When Eugene was a student, one of his university professors was consulted by a high-ranking government official responsible for regulating the electric utility industry. Eugene's professor had to explain to this government official that what he was asking for violated Kirchhoff's current law. The government official responded by asking, "Can't we just repeal it?" The sad thing is that he was not joking. The laws of physics do not change, and it's important to be able to differentiate these laws from various arbitrary social conventions humans have created. Many textbooks focus on things like the precise definitions of technical terms and which variable symbols we need to use. However, these all fall into the category of arbitrary social conventions, and not everyone uses the same conventions. Different textbooks often use different variable symbols and different technical terminology, even when these textbooks are published in the same language and in the same country. And all these social conventions will obviously be completely different for different alien civilizations throughout the universe. Here on Eugene's Physics YouTube channel, the focus is on trying to understand the actual underlying laws of physics which we all share throughout the universe, as this is what makes physics fascinating. It's now been exactly 10 years since Eugene started publishing videos for this channel. Throughout the years, even students with the best grades, who have always been able to correctly solve all the equations, have stated that they didn't really understand what it was that they were doing until now. Many people have written comments saying that they learned more by spending a few minutes watching one of Eugene's videos than they did during their entire university education. This begs the question of what exactly are the colleges and universities spending all their time on? if they end up teaching less information than a short video? In many cases, the answer is that they spend a lot of time practicing with different examples. However, regardless of how smart you are and regardless of how much you practice, this alone will not cause you to learn the subject matter. As an analogy, suppose you want to learn how to add two numbers together. One approach is to go through many examples and memorize the answer to each case. This strategy will work if the number of cases we care about is relatively small. If the number of cases we care about is large, this memorization process becomes much more time-consuming and much more difficult. But it can still be done with sufficient determination. Nevertheless, regardless how much time you spend practicing with different examples, you will never be able to memorize every possible case, since there is an infinite amount. By contrast, it only takes a few minutes to learn the rules for long addition. Once you know this, you will be able to add any two numbers together, even if you have never seen them before. Spending a few minutes learning long addition is far more valuable than years of practice at memorizing the answer to every example you encounter. It may not be as obvious, but the same principle is true for many areas of physics, advanced mathematics, and engineering. Though, what is fundamentally important in these cases is not learning the procedure for finding the correct answer to a set of equations. What's important is understanding the underlying principles that these equations represent. Even if you have never seen the equations, if you have a mental picture of the underlying principles, you will be able to derive the equations yourself, and the answers to many questions will be obvious. By contrast, if you start out by only being given the equations, it might not be possible to ever derive a mental picture of what's actually happening. And it's this mental picture which is critical. The use of examples can help clarify the key principles, provided that these examples are initially as simple as possible, even if an example this simple will never occur in real life. By contrast, if complicated examples are used when first exploring a new concept, the key principles will be buried under a lot of extraneous details and mathematics that are unique only to those particular examples. Hence, the actual key principles are lost, and people instead end up focusing on the procedures and strategies for solving the specific examples they're exposed to. This is like memorizing strategies for playing chess, without ever understanding the rules for how the pieces move. Once you learn how the pieces move, you can develop your own strategy, and this might be far superior to any strategy anyone will ever teach you. We hope you've enjoyed this video, even if you didn't agree with the opinions expressed. Future videos will return to teaching physics and mathematics, without opinions interjected. Though, if you want to read more about Eugene's opinions on a variety of subjects, the links to his personal websites are on his Patreon page. The link to the Patreon page is available in the video description. Special thanks to all the people supporting this channel on Patreon. Your support is very much appreciated.